Hi everyone, welcome back to another GCSE Maths lesson with Morale. Today we're going to solve some real life ratio problems. So our focus today is going to be on ratios. I'm going to look at several examples. Now, let's get started. First things first, let's look at some key vocabulary. First of all, what is a ratio? So a ratio is a way to compare two or more quantities. So for example, a typical example would be if you're cooking, or a recipe basically. So we could say, let's say we're making a cocktail. We could say for every 2 parts of orange juice, for every 2 cups of orange juice, we need 3 cups of apple juice. I'd like to know what kind of cocktail we're making, but that's what it is. And that's basically what a ratio is. So a ratio is a way for us to compare 2 or more values and things. So you can have more than 2 parts. So you can have, let's say, oranges with apple juice with cranberry juice. So you have 3 parts, and you can say for every 1 part of orange juice, we have 2 parts of apple juice and 3 parts of cranberry juice, for example, so that you follow that recipe. Proportion in that case is when 2 ratios are equal. Every 1 part of orange juice, I have 2 parts of apple juice and 3 parts or 3 cups of cranberry juice. So then I'm saying, okay, this is if you want to make 1 jug of this drink. But if you want to make 2 of them, then all you're going to do is you're going to double everything. So that's going to be 2, that's going to be 4, and that's going to be 6. So these 2 ratios are basically the same, but they're going up or down in the same proportion. So if we're doubling it, we're going to double everything. If we're halving it, we're going to half everything, and vice versa. And that's what a proportion is. Basically saying that these 2 ratios are equal, right? A unit ratio would be where one of the values is equal to 1. So if I have orange juice to apple juice, and I'm saying orange is 1, this is a unit ratio. Right, when either one of these 2 can be 1. Scaling up or down basically means adjusting the ratio by the same amount, by the same proportion. So multiplying it or dividing it. So you're going to double it, you're going to double everything. If you're going to divide it, you're going to divide everything. So multiplying it scales it up, dividing it scales it down. Right? Hope that makes sense. Part to part or part to whole basically just means part to part means where you're comparing 2 parts of the same group. And part to whole would be when you are comparing 1 part to the total. Right? So if I'm going back to this ratio, part to part would be where I'm comparing the orange with apple or cranberry. Part to whole would be where I'm comparing the orange to the whole thing. So right now, let's say I have a total of 6 parts. Right? If we add each of these parts, I have a total of 6 parts. If I say out of the 6 part, 1 part is orange, I'm comparing 1 part to the whole thing. So that's part to whole. But then if I'm saying for 1 part of orange, you need 2 parts of apple, then I'm comparing part to part. So that's basically what that is. Those are the key vocabularies that will help you understand ratios better. Now, why are ratios so important? So ratios appear in everyday life, such as cooking. So if a recipe says 2 cups of flour for every 1 cup of sugar, that's a ratio. If you have a map, there's always a little scale that would say something like 1 to 1,000, right? That would mean, and the unit would be centimeters, so that would be every 1 centimeter on paper represents 1,000 centimeters in real life. So when you have a map of the world, or if you have a map of your area or map of your city, that tiny little map that you have, of course, is not to scale. It's not the real size of it, and you can't draw the real size, otherwise it will be as big as the whole town or the whole country. So in order to do that, they make it smaller, they descale it in a sense, they make it smaller, but then they put a little scale at the bottom of the map to say that every 1 centimeter in real life, if you take a ruler and measure 1 centimeter on a map, it represents 1,000 centimeters in real life. Right? Hope that makes sense. And then you also use it in money exchanges, so exchanging from pounds to dollars, dollars to pounds, and vice versa, for discounts, for financial calculations. All of these things rely on ratios, which is important to understand it. Okay, so let's start with the first basics of ratios. So a typical question you could get on ratios would be something like, give you a ratio and then they'll ask you to simplify the ratio. So write the following ratio in its simplest form. So the key word there, it's simplest form. That means we're going to find the factors of these 2 and divide both parts by the same number. So let's say I divide by 2, that would 12 divided by 2. So if I divide that by 2, 12 divided by 2 gives me 6. 16 divided by 2 gives me 8. Right, I have 6 to 8. It's simpler than what I started with, but it's not the simplest form. I can keep going. So I can divide it once again by 2, and that will give me 3, and once again by 2, and that will give me 4. And that is the most simplified answer. Now, the trick to this would be, if you're simplifying, always find the highest common factor between these 2 numbers, and then divide it. However, sometimes we just can't remember the highest common factor that goes into both of these numbers, because the numbers could be different numbers that you're not familiar with, or bigger numbers. So if that's the case, just divide. and keep going until you cannot divide anymore, until you cannot simplify it anymore, right? Always remember that. You could also get something like this, where it says, write the ratio of 12 to 60 in the form of 1 to n. So 12 to 60 in the form of 1 to n. So it's telling us, if it gives us this format, it's telling us that this one is equal to 1. So if this one is equal to 1, what is the value of n? So we always remember one thing with ratios, whatever you do to one part, you always do it to the other parts as well. So we look at this, how do we go from 12 to 1? I've divided this by 12. So that means I'm going to do the same thing to the other part. I'm going to do 60 divided by 12, which gives me 5, right? So that is in that format. So the part that they want to equal to 1, that is the part you start with and focus on. And then you do the same to the other part, right? Hope that makes sense. Let's keep going. Now, another type of question that you can get is something like this, where you use ratios to find a missing value. So it says, a recipe for 3 people uses 6 eggs. How many eggs would be needed for 9 people? So first of all, we're going to write that down. So the ratio is 3 people. For 3 people, 6 eggs are needed. So the ratio is 3 to 6. Now, if we want to know, so this is people, and this is egg. So we write them in the same order. So if you want to know how many eggs are needed for 9 people, we look at it like this. How do I go from 3 to 9? I'm multiplying it by 3. We're scaling up because we're multiplying. We're going to do the same thing to the other side. We're going to multiply it by 3. That should say 3, sorry. So 6 times 3 gives us 18. So the ratio is 9 to 18, right? So if we have 9 people will require 18 eggs based on the initial ratio that was given to us. So that is what we call a proportion. We increase both parts by the same proportion. The recipe uses flour and sugar in the ratio of 4 to 3. If you have 800 grams of flour, how much sugar is needed? So again, with these ratio questions, it helps when you write things down. So ratio of flour to sugar is 4 to 3. So if I have 800 grams of flour, how much sugar do I need? Now, clearly, we can see clearly that it's scaling up. So we look at it in terms of, okay, how are we going from 4 to 800? Whatever we do to this side, we're going to do the same thing to the other. So we can ignore the zeros. To go from 4 to 8, we're multiplying it by 2, and then we can add the zeros in. So 200, we're multiplying by 200. We're going to do the same thing to the other side. 3 times 2 gives us 6. We add the 2 zeros. So for every 800 grams of flour, 600 grams of sugar is needed for this recipe. Let's keep going. A cake recipe, so let's look at this question. A cake recipe needs 200 grams of flour and 300 grams of sugar. What's the flour to sugar ratio? If you want to double the recipe, how much of each ingredient will you need? Okay, so let's answer the questions part by part. So it says, so if the ratio of flour to sugar is 200 grams to 300 grams, what's the flour to sugar ratio? This is the flour to sugar ratio. If we want to give the most simplified answer, we're going to divide both sides by the highest common factor, or by any factor, and just keep going until we get to the most simplified answer. Here, we have 2 zeros in front of both, so we can divide both by 100. And the most simplified answer would be 2 to 3. Right? If you want to double the recipe, how much of each ingredient will you need? Now, the second part of the question says if you want to double it. So we're scaling up by 2. That whatever we do to one side, we're going to do the same to the other. So if we double this, gives us 400 grams. We're going to double the other one as well. And we have 600 grams. So for every 400 grams of flour, we need 600 grams of sugar. Using ratios in shopping. A shop is selling oranges for £2. How much would 10 oranges cost? Number to cost ratio. So for 4, it's £2. How much would it be for 10? So we can do it in this sense where we look at, okay, how do we go from 4 to 10? Whatever we do to this side, we're going to do the same to the other. However, we know that 10 is not in the multiplication table of 4. So 4 is not a factor of 10. 10 is not a multiple of 4. So we know it's going to involve decimals. So in this case, where we got odd numbers, we always do it like this. We look at, okay, 4 oranges, the cost is £2. How much would 1 orange cost? And then whatever that is, we can multiply it by 10 to get to 10 oranges. So we do 4 divided by 4 to get to 1. We do the same thing to the other side. 2 divided by 4. And 2 divided by 4 is 0.5. Now, if you're not sure, we can always do a little side calculation. 2 divided by 4. 4 goes into 2 0 times. We've reached a decimal. Place a decimal point there. We carry the 2 over. 4 goes into 20 5 times. So 2 divided by 4 is equal to 0.5. We then look at it, Okay, the cost of 1 orange is 50p. What would the cost of 10 oranges be? So we're going to multiply that by 10 to get to 10 oranges, and the cost of 0.5 by 10, which is going to give us £5. So 10 oranges will cost us £5. Right? Hope that makes sense. Let's keep going. Let's look at a map example or a scale example. So a map has a scale of 1 to 5,000. If the distance between 2 points on the map is 3 centimeters, what is the real world distance? Okay, so we're saying 1 centimeter on paper represents 5,000 centimeters in real life. So if on paper it says we measure 3 centimeters, again, we're scaling up, so we're multiplying that part by 3. We're going to multiply the other part by 3 as well. 5 times 3 is 15. We're going to place the zeros in front. So 3 centimeters on the map represents 15,000 centimeters in real life. Now, so it says, what is the real world distance? Typically, we don't say it's 15,000 centimeters. But the question would typically say, give the answer in meters. How many meters does that represent in real life? Now, when it says real world distance, is indicating that, but they would say that very clearly in an exam. So then we say 15,000 centimeters. What would that be in meters? So 1 meter is equal to 100 centimeters. So that means to go from centimeters to meters, we are dividing by 100. So we're going to do the same thing here. So if I have 15,000 centimeters and I want to convert to meters, I'm going to divide by 100, which means let's look at a simple ratio problem involving money. Now, Will and Ollie share £80 in a ratio of 3 to 2. Work out how much each of them get. So the first thing we need to figure out, how many parts or shares are there altogether? So Will and Ollie, Will gets 3 shares, Ollie gets 2 shares. So the £80 is being split amongst a total of 5 parts or 5 shares. So if we add these two together, we get 5 parts. So the money is being split into 5 shares or into 5 parts. So first things first, we need to figure out what is 1 part equal to. Once we know what 1 part is equal to, then we can calculate 3 parts and then 2 parts as well. So to figure that out, we're going to take the total amount of money, which is 80, and divide it by the total number of shares, which is 5. 80 divided by 5 gives us £16. Now, to find Will's share, it's 16 times 3, which is £48. And Ollie's share is 16 times 2, which is £32. And you can always double check your answer by adding these two together. So here, 48 plus 32 should give us the total amount, which is 80. 8 plus 2 gives us 10. Put the 0 down, carry the 1 over. 4 plus 1 is 5, plus the 3 is 8. So the total is £80. So we use that method to double check our answer, right? Hope that makes sense. Now let's look at some tips, some simple tips for solving ratio problems. Now, first of all, always remember, if we do a similar question to like the previous question that we've just done, you need to identify the total parts in the ratio. So this person gets 3 shares, the other person gets 2 shares. So how many parts do we have as a whole? So we need to find out the total parts so that we can calculate 1 part, and then from there we can find however many parts that the question is asking us to do. So find the total, identify the total parts, and then identify the individual parts. Use proportional reasoning. What that means is if you increase 1 part of the ratio by a certain amount, increase the other part by the same amount. Whatever happens to one part of the ratio will happen to the other part as well. If we're doubling it, we're going to double all parts. If we're halving it, we're going to half all parts. So go up and down by this using the same proportions. And always check your answer, like the previous question we've just done. Whatever answer you get for each part, add it together and see, do I get the total amount that was given to me? To double check your answer. Now, let's quickly look at some common mistakes and how to avoid them as well. So the first one would be forgetting to use the same units. So for example, if you are creating a recipe for a drink and mixing milliliters in all parts, and the question wants you to give the answer in liters, make sure everything that you're using is in the same unit, and then you use the appropriate conversion. Or if you have the scale of a map, make sure you read the question very carefully. What unit is given to you? Is it centimeters? Are they asking you to give the final answer in meters or kilometers? Make sure you don't just assume that the units that they're giving you is kilometers, so you're going to calculate and then say this is kilometers. No, most probably it's centimeters, and then you convert it to what is needed. So that's the first thing. Second thing would be not simplifying ratios properly. If a final ratio that you give, for example, is 12 to 16, make sure you simplify it accordingly. If you divide this part by 6, which gives you 2, you got to do the same thing to this part as well. Either you're going to get a decimal point or that is not a factor. So we're going to go back and say, okay, rather than dividing it by 6, I'm going to divide it by 2. So that's going to give me 6. And if I divide that by 2, I get 8. However, that is not the final answer. I can simplify it once again. I can divide it by 2 and get 3 and 4. So make sure you use the right You divide both parts by the same factor and make sure you keep simplifying until you cannot simplify anymore. So this would not be the most simplified answer, this one would be. So don't forget the last step. And then finally, a common mistake is scaling incorrectly. So always multiply and divide both numbers in the ratio by the same value. So like I said, whatever you do to one part, you always do the same to the other as well. So always remember that. Right, now it's your turn. Try solving this ratio problem. Let me move my face out of the way. A school has a student-to-teacher ratio of 18 to 1. If there are 540 students, how many teachers are needed? So pause the video and have a go and leave your answers in the comments, and I will let you know if you got the correct answer or not. Right, so that wraps up today's lesson on solving real-world ratio problems. If you found this to be helpful, don't forget to like, subscribe, and share with your friends. Hit the notification bell so you don't miss the next video that we have coming out on past paper exam questions on ratios and percentages. So that will definitely be helpful in your revision. And see you next